All right, in today's lesson, we're going to talk about something that a lot of students hear the word and they think of an animal, and that is the mole. And a quick Google search, if you were to go on Google and you were to type in the mole and then chemistry, what you would get back is a lot of information. And if you do an image search, you would see all kinds of pictures of moles in chemistry, and I'll explain what a mole is. But it's a fun, the mole, the animal, is a fun way to kind of visualize what a mole is. But it's actually not that; it's a number. So let's take a look at this thought experiment, or this thought problem. And let's say I had 26.98 grams of aluminum. And if you remember from the last video, that 26.98 grams for aluminum. So how many, sorry, if you heard that, was my phone ringing. How many grams of copper would that be equal to? And I think I've said this in a previous video, but this is a little chem joke. What did one copper atom say to the other copper atom? See you later. Well, what we can do is we can use what we know about AMUs for each substance. And I could say this. I could say one aluminum atom is, let's do it in black. I could say one aluminum atom is 26.98 AMUs. And then I could also look on the periodic table and I can see that copper, and we can look on the periodic table and we can see for copper that one copper atom is 63.55 AMU. Well, since we have this ratio with the mass of one atom, we can set this equal to the ratio of the masses of our aluminum and copper sample. So I'm going to take this, set that on top of the ratio, 26.98 grams. And so we can say that 26.98 grams of aluminum would be equal. And you could see this ratio is actually very easy, right? We've got the same number here on top, so it's going to be the same number at the bottom. Whoops, that's copper. But what we see here is that 26.98 grams of copper, 26.98 grams of aluminum, has the exact same amount of atoms as 63.55 grams of copper. So you can probably imagine that this ratio extends to all elements, right? If we're looking at aluminum and copper, and this is the mass of each atom, then it probably would make sense that 26.98 grams of aluminum would be the same as 12.01 grams of copper. Again, if you're wondering where this comes from, it's the mass number, the average atomic mass on the periodic table, which, pick an element, would be equal to, let's say, 4 grams of helium. And that this is helium's atomic mass. So you could pick an element, and if you have the atomic mass amount in grams, that you would have the same number of atoms. So now we're going to define a mole, and a mole is a number that is equal to the number of carbon atoms in 12.01 grams of carbon. It's also known and named after this scientist from the 1800s. His name is Avogadro, and it is Avogadro apostrophe S, Avogadro's number. And what it is this. It is a 6 with 23 zeros after it. So it's 6 billion of something. And we abbreviate this number in scientific notation. You don't want to write that every time, so Often, here, let's do this. 6 point. So Avogadro's number, 6.02 times 10 to the 23rd. Don't be thrown off by this. We already use words to represent numbers, right? 12 donuts, or 12 of anything, is 1 dozen. A dozen roses, a dozen donuts, right? We hear dozen, we think 12. This is, if you count this up, there are actually 13 cupcakes here. This is what is known as a baker's dozen, and it is 13 because the baker would always eat one of the cupcake, donut, bread, whatever it was. And this is a one you may or may not know. This is called a ream. So 1 ream of anything, we usually use it with paper, is 500 of that thing. So a ream of paper is 500 pieces. So since you're familiar with that, if we had, imagine a pile of atoms, 1 mole would be 6.02 times 10 to the 23rd of that substance, whatever it is. Now, if you look on the periodic table at the atomic mass, that will tell you how many grams are in a mole, how many grams a mole of each substance weighs. So a 1 mole of copper atoms, we've already done this, would have a mass of 63.55 grams. 1 mole of sodium atoms would have a mass of 22.99 grams. 1 mole of copper atoms would have a mass of 12.01 grams. And what you see is, even though these are different masses, they would weigh different amounts, there would be the exact same number of atoms in each sample. And you can imagine, think of it this way. Here I've got a situation where I've got a dozen ping pong balls. So this is 1 dozen ping pong. I'll just do ping pong balls. And here I've got 1 dozen bowling balls. Now, if I were to take one of those old balances, like this, right? And I were to put my bowling balls, whoops, let's get rid of that. And I were to put my bowling balls, let's see if I can do it. Maybe I can't. Oh well. If I were to put my bowling balls on the balance and put my ping pong balls on the balance, you could imagine that the picture would look, that the bowling balls would be much, much heavier. But if I were to ask you, which one do I have more of? Well, a dozen of anything is the same number. So we could count up the ping pong balls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got the same number of bowling balls as we do ping pong balls. So even though the number is equal, the mass is not equal. And that's okay. And that's the same with chemistry. A mole of carbon does not have the same mass as a mole of copper, which does not have the same mass as a mole of aluminum, and so on and so on and so on for all the elements.